Hello everyone and good morning. Welcome to another calculus class. In today's class we are going to introduce derivatives. This is personally my favorite topic and I'm sure that you're also going to like it. But before we start our today's topic, I would give you a very quick recap from our previous class where, if you remember, we were evaluating limits analytically. Yeah, so that's what we are going to do. I'm just going to give you a very quick recap on that, and before introducing our today's topic, which is introduction of derivatives, we'll go through a very quick knowledge check, because I just want to find out if you still remember those small tidbits of mathematics that we are going to use in today's class. And if you don't know, that's fine. If you've forgotten, that's okay with me, because that will give me an opportunity to just give you a recap on those topics as well. And all these ingredients, when we'll combine them, they will help us in understanding today's topic, which is finding the derivatives using limits. So let's begin. Our first question, this is the question that we did in the previous class last week, so I thought it might be a good idea to redo this question with you, and if you have any questions, you're most welcome to ask. So our first question is limit x approaches to 3, and you can see there is a small superscript plus. That's it. That means the x is approaching to 3 from the positive side. So can anyone tell me what does that mean? Like, if we have this positive sign over there, what does it signify? Yes, you're right. The limit is one-sided limit. It means the x is approaching to, so let me just do this for you. This is the 3 that we are looking at. So x is approaching to 3 from the positive side. So we are now going to see that what effect this limit when x approaches to 3 is going to have on this function. So let me rewrite it for you. So we have limit x approaches to 3 from the positive side, and this is our function. All right, now before I start solving this, just a quick reminder. When we were discussing the limits, we discussed that x approaches to a particular number. It goes towards that number, but this x is not this number. So basically the idea of limits is when x approaches to this number, what effect does this thing have on the value of y, which is our main function. All right, so this is basically you need to keep in mind. So x is approaching to 3 from the positive side. It's going towards 3. So no matter how close it gets to 3, remember this thing, that this number is still going to be positive. Yeah, this number is still going to be positive even if it gets very, very close to 3. Like, for example, let's think of a number, let's say 3.0000001, right? So this number is still positive because it's bigger than 3. Yeah, it's bigger than 3. So see, when x, which is slightly bigger than 3, yeah, what effect does it have on the numerator? The numerator would be, when x will approach to 3, the numerator will approach to, if you remember, it will approach to minus 13, isn't it? It will approach, let me write it down, approach to minus 13. Look at this one. When x will approach to 3 from the positive side, so this number is going to be slightly bigger than this one, yeah? This whole function will approach to 0, but from the positive side. So it's going to approach 0 from positive side. Okay, now look at this. Use your basic algebra knowledge. Negative divided by positive gives you negative. Anything divided by 0 gives you infinity, undefined. So that means when x approaches to 3 from the positive side, the limit, this function, is going to approach to negative infinity. And you can see it here. You can see it here. I've already drawn the graph for you. See, on the positive side, so we are talking about this side. Look, when the graph is going, when the x value is going towards x, the y value is going towards negative infinity. That basically verifies the result that we just got. Look at the second one. Now for the second one, I'm going to use a different color. Now this time x is going to approach to 3 from the negative side, as it says here. So we are going to see that when x approaches to 3 from the negative side, where is this y gonna go? So let's rewrite it. Limit x approaches to 3 from the negative side. So we have 2 minus 5x over x minus 3. Now remember, this x values, these x values are going to be slightly less than 3. Slightly less than 3, right? So look, when x value, now when I say slightly less than 3, let's talk about, I'm talking about 2.999999995, probably. Yeah, slightly less, any value which is slightly less than negative 3. I'm sorry, slightly less than 3. So let's say if I put a 3 here, yeah, so I have 5 times 3, 15. 2 minus 15 is going to give me minus 13. And now this number is slightly less than 3. When this number is slightly less than 3, this is going to approach to 0. It's going to approach to 0, but it's going to be negative, isn't it? It's going to be approach to 0 but negative. So according to the algebra skills that you claim that you have, negative times negative divided by negative gives you positive, and anything divided by 0 is infinity. So this means when in this particular function, when x approaches to 3 from the negative side, the y value approaches to positive infinity. And you can check this out also on the graph that I have put for you. See, when x is going towards 3, so it means we're talking about this part of the graph, right? And look at the y values. The y values are going high towards positive infinity. So that verifies the results. Right, moving on. Can anyone remind me of the difference between the tangent line and the secant line? Anyone? Right, you are right. So the tangent line is a line that touches the curve at exactly one point. At exactly one point. It's the tangent line. And the line that intersects the graph at multiple points, more than one points, is called the secant line. Very good. So what I want you to do is I want you to just keep this thing in your mind, all right? Because we're going to use it in our next slides. Another thing, another very quick question. Can anyone define the slope of a line for me? What is the slope of a line? Yes, you're right. Slope or the gradient is rise over run. Rise means going up and down. Run means going across, left and right. There is another way to remember this thing. Remember, the sun rises, yeah? So it goes up and down. You run on the ground, so you run like this, yeah? So remember this thing. Rise means going up and down, and when I say up and down, when we have rectangular coordinates, it's basically the movement along y-axis, and this is the movement along the x-axis. Now, if I want to explain it a little further, yeah, so let's say we have two y values, y2 and y1, yeah, divided by the difference in 1. The rate of change in the value of of y is in the numerator. It's the rise, the change in the value of y, okay, the rate of change in the value of y, and the change in the x values is the run. This is basically the formula for the slope. We can always modify these kind of formulas. Look, y, we know that y is basically f of x. Yeah, that's a different notation, right? So how about if I have y2? Can I write it as f of x2? Sure, I can. Because for a second value of x, this is the corresponding value of y. Similarly, y1 should be f of x1. You're right, f of x1. So how about this? if I just rewrite this thing like this, f of x2 minus f of x1 divided by x2 minus x1. This is called the slope or the rate of change, the average rate of change. Yeah. So basically we are going to use these concepts in today's class. Guys, there are two things that I want you to remember. Look, for example, if I ask you that I did a test and my score was 90 out of 100, what's the average? You would say, but there is only one number. There's no need to find out an average because there is only one number, 90, right? How about this? If I asked you that I did two tests and in one of the tests my score was 80, in another test my score was 90, what is the average? Now it's easy for you to answer that question. You would say, okay, 90 plus 80 divided by 2, and that's going to give you 85. So that's the average, right? That's the average. So that's what I want you to remember now. I'm sorry, you have to remember now. You can find out the average of two numbers. You can find out the average of two numbers, three numbers, four numbers. But let's say for now you can find out the average for two numbers. And remember the secant line. The secant line. We said that the secant line is the line that intersects the graph or the curve at least 2 points, no less than 2 points, right? So which means when you find out the slope of the secant line, it's called the average rate of change. Average rate of change, because the secant line intersects the graph at 2 or more points, right? What about the tangent line then? The tangent line intersects or touches the graph at exactly 1 point. When we talk about 1 point, I'm talking about this time, at the moment, at this instance, This is called instance, right now, instance, right? So when the slope for the tangent line, because tangent touches the graph at 1 point, so we are basically going to find out the slope at that particular instance. That's why we call it instantaneous rate of change. So these are the two things that I want you to keep in mind, okay? Average rate of change and instantaneous rate of change. So once you have understood these two things, we are ready to move on to the next thing. Guys, look at this graph that I drew for you. Check it out. So I have 1 point, I have another point, and this is the value, this is the point that has coordinates y is equal to f of x at the value of x, right? Now we start moving this value of x towards a. When we move this one, the y also moves. Now for this particular value of x, this is the y value. We keep moving, and now for this particular value of x, this is the y value, right? Keep looking at my two hands. Look, as I go close to the value of a, I reach to this point, isn't it? I reach to this point. So basically, look at this line. See how this line will move when this point will move to this one, this point will move to this one. See how this line is going to move. This line is now going to be this line here. This line is going to be this line here when you move. So as you keep moving, at the end you will have one line. So basically, as we move towards x, our secant line became the tangent line. So that's a very important thing that I want you to remember. So this is f of x, this is f of a here, right? So the change in y, f of x minus f of a, right? Divided by the corresponding values of x, x and a. The change in y divided by the change in x, that becomes the change in x, the change in y, I'm sorry, and the change in x. Yeah, what do you think? Is it going to be the average rate of change or the instantaneous rate of change? You're right, it's going to be average rate of change, and average rate of change corresponds to what? Correct, the slope of the secant line. However, I just told you, when we start moving this x towards a, this secant line becomes the tangent line. So look, if I limit x approaches to a, the same thing, which was the average rate of change, has now become the instantaneous rate of change, which means this is now the slope of the tangent line. Is there any question? Anything? Anyone wants to ask anything? Or if you have any doubts, this is your time, you can ask me. All right, if not, then we will move on. So this is what I just told you about the average rate of change. All right, so for this example, as you can see, we have f of x is minus x squared plus 6x, and consider the point P1 and, my mistake, I'm sorry, it should be 5, P1 and 5 on the curve. So we first have to find out the slope of the line tangent to the graph. So what I'm going to do is I'm going to go to Desmos, because it's always good to visualize, because as we always say, you learn more when you can visualize. Plus 6x. So this is the graph basically that we are looking for. Minus x squared plus 6x, and then there is a point on this curve which is at 1 and 5. So this is the point that we will be looking at. All right, so this is the curve minus x squared plus 6x, and this is the point on that curve. So going back to our presentation here, and I'm going to present it here, and so let's start finding out the slope of the tangent line. And remember this thing, we said because the slope of the tangent line is the instantaneous rate of change, so we have to have limit x approaches to a, f of x minus f of a divided by x minus a. Now in this case, the particular value of a is 1, which is the value of x here. So limit x approaches to 1, f of x minus, and I'm going to change the color here because we will be using this, divided by x minus 1. Right, it might be a good idea, because we have f of x, which is minus x squared plus 6x, so it would be a good idea to find out f of 1 separately. It's going to be minus 1 plus 6, and this is going to be 5. Okay, that is correct. So f of 1 is 5. So let's do this here. Limit as x approaches to 1, f of x, which is minus x squared plus 6x, and we just found out y f of 1 to be 5. And then we have x minus 1. All right. What we're going to do now is, if you just recall your memories, how we solved the limits, such limits analytically. Excuse me. So according to this, if I simply factorize the numerator, I should have minus x minus 5 x minus 1 whole divided by x minus 1. And as you can see, this can be cancelled, and I'm sorry, I forgot to put the limit, which is approaches to 1. So we have limit as x approaches to 1, we have minus x minus 5. Applying the limit, we'll have minus 4 and a minus outside, so 4. So what we just found out is the slope of the tangent line. So the slope of the tangent line is 4. In the next part of the question, we have to find out the equation of the tangent line. So for this, I'm going to use the point slope formula of the line, is m tan x minus x1. So it's going to be y minus, we are going to use the same point. So the y value here is 5, m tan we just found out to be 4. And I'm going to change the color so that you can see this is the 4 that we found out from there, and then x minus 1. And So y minus 5 equals to 4x minus 4, and so y should be equal to 4x plus 1. So this is the equation of the tangent line, and just to verify my answer, I'm going to go back to Desmos, and here I'm going to write down the equation of the tangent line that we just found out, which was 4x plus 1. And if I just delete everything that I just did, you can see that this line is a tangent to that curve. So that was pretty much it for today. I hope that you have learned this topic, and if you have any questions, you're most welcome to come to my office and meet me there, and we can sit down together and we can discuss these things. So thank you very much. I'll see you tomorrow then.